12, and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Maths Standard 2. This is part 3, question 20, 21 and 22, worth 11 marks. Question 20. The graph of a quadratic function represented by the equation h equals t squared minus 8t plus 12 is shown. Find the values of t and h at the turning point of the graph. Pause here to try yourself. Okay, so they're inviting us to find the coordinates of the vertex. We know that the vertex of a parabola, by symmetry, the x-coordinate will be the average of the two routes where it cuts the x-axis, in this case t. So the average of 2 and 6, 2 plus 6 all over 2 is 8 on 2, which is 4. So we know that t equals 4 at that point. So the first is 4. Now we need to evaluate what is h when t is 4. So at t equals 4, using the rule, h equals 4 squared less 8 lots of 4 plus 12. 16 less 32 plus 12 is minus 16 plus 12 equals minus 4. So the values of t and h at the turning point are t equals 4, h equals minus 4. The coordinates of that turning point are 4, minus 4. Part B says the graph shows h equals 12 when t equals 0. What is the other value of t for which h equals 12? So they're telling us that h equals 12 there at 0, 12. Where else is h equals 12? So I know by symmetry, if there's a distance of 4 from there to there, there must be a distance from 4 from there to there. So that point there has coordinates 8, 12, because the t coordinate is 4 more than 4, which is 8. So the other value of t is t equals 8. Question 21. A house has a reverse cycle air conditioner which uses 2.5 kilowatts of power for cooling and 3.2 kilowatts of power for heating. The cost of electricity is 29 cents per kilowatt hour. Part A. Find the cost in dollars and cents of cooling the house for 6 hours. Pause here to try yourself. Okay, so cost equals price times usage. Okay, so the cost is 29 cents per kilowatt hour, regardless of whether it's cooling or heating. The usage in this case is 6 hours, each of which is consuming for cooling 2.5 kilowatts. So put all of that into your calculator. 0.29 times 6 times 2.5. I get 435, and that's in dollars and cents. That's the answer to part A. Part B, the cost of operating the air conditioner to heat the house during winter last year was $640. There are 92 days in winter. Find the number of hours to one decimal place that the air conditioner was used on average per day. Pause here to try yourself. So again, cost equals price times the number of kilowatt hours in question. So the cost side we do know. So 640 in dollars equals a price of 0.29 times 3.2, which is the kilowatt hours for heating, multiplied by an unknown number of hours multiplied by 92 days in winter. So we know everything except h. Let's rearrange to make h the subject of that equation. 640 divided by 0.29 times 3.2 times 92. I can put all of that into my calculator. 640 on top, 0.29 of 3.2 of 92 I get 7.49625 and so on. But it's approximately 7.5 hours per day. Question 22. A network of pipes with one cut is shown. The number on each edge gives the capacity of that pipe in litres per minute. What is the capacity of the cut shown? Pause here to try yourself. Okay, so that cut impacts this one and this one and this one and this one and this one, but I only want to count the ones that are in the same direction as source to sink. So I only want to count that one, I only want to count this one, and I only want to count this one. I can ignore those going from sink to source. So I ignore the 8, I ignore the 6. So the capacity of this cut is 26 plus 24 plus 12, which equals 62 in litres per minute. Part B. The diagram shows a possible flow for this network of pipes. Part 1. What is the value of X? Give a reason for your answer. So X is here. Well, I can see that X is approaching the node at C, and the inflow at C must equal the outflow at C. So X must be the sum of 5 plus 13 plus 12. So X equals 30. Part 2 says which of the pipes in the flow are at full capacity. So in order to do this, I need to compare it to the capacity I was given before. So I was told before that the capacity here was 24, the capacity here was 35, the capacity here was 14, the capacity up here was 26, the capacity here was 15, the capacity here was 24, the capacity here was 8, the capacity here was 17, the capacity here was 12. The capacity here was 11 and the capacity here was 6. So I'm noticing all of those where the flow is at their capacity because the numbers match. So that one matches and that one matches. This one matches and this one matches. So the pipes in the flow that are already at the capacity are D to E, C to F, D to G, and F to G, because the flow is the same as their capacity. Part 3. The maximum flow for this network is 50 litres per minute. Which path of pipes could have an increase in flow of 2 litres per minute to achieve the maximum flow? All right, so I certainly can't increase anything which is already at capacity, which were my answers in the previous part. That eliminates DG and FG. So in order to increase the flow, I'm going to need to rely on this path from E to G, and I notice that I can. It's only at 22 at the moment, so it could be lifted to 24. I have capacity here from C to E, and I know that I also have capacity from A to C. So the path which I could increase is A, C, E, G, because it's not currently at capacity.